What is a state? I mean, thermodynamic states. Jesus. Thermodynamic state. It is identified by value of a suitable set of parameters known as state variables. Once such a state of value of thermodynamics variable has been specified for a system, the values of all thermodynamic properties of the system are uniquely determined. Yes, that doesn't make any sense, right? So let me give you another unrelated example. Okay, so let's say I have different version of this dog, and I ask the question, what kind of information that you can use to identify this different version of dogs? Okay, I'm asking you to list the information. Okay, so let me give you an example. So I think that in order to identify these different types of different version of the dog, I would need an information like an age, okay, weight, fur color, height, body length, leg length, and a lot more information. Okay, so I'm just listing everything that I can think of. Okay, and this information is just called properties. So if you think of the dog as a system, then all this information are properties of the systems. Okay. So once you identify the property of the system, then so the state is just a suitable set of property. So what do I mean by suitable set? A suitable set is just the set that is unique enough so that information are not redundant. For example, this property that a lot of information are just kind of insignificant, right? I think that I only need four. These are the most important information in order to identify different version of the dog. I don't need other informations. But once I know this four information, I can figure out the rest of the information. For example, if I know this four information, I can figure out what the leg length is, something like that. Okay, so that's the meaning of the state. It's just a suitable set of property or just a number. Okay. So once you identify the state or the suitable set of information, you can now label your system. Okay. For example, look at the dog on the left side. I can label it state number 1. Okay, this is the old dog. It has it's 7 years old, heavy, 30 kilograms, 1 meter and 1.5 meters, something like that. Okay, the dog on the right side is a younger dog. It's 1 year old. It is labeled state number 2, 1 year, 5 kilo, and so on. So I just want to point out that when you talk about state, you can also think about just a set of number, okay? And that will make things a lot clearer further on in this course, okay? Another thing that you can do is that once you study your system long enough or with certain amount of details, then you can start to make prediction, right? For example, I might ask the question of, for example, this state number 3, so this dog right here, okay? If I were to know the 3 information, can I figure out its age? Can I predict its age? So that is a valid question, and actually it's a very thing that we do in thermodynamics to predict the system behavior, okay? And in order to do that, if you were to predict something when you have an input value, it was as if you would have to, have some sort of relationship between this information, right? To make this kind of prediction, we need to know relationship between this information or variable. Essentially, you have to know the equation, basically, right? So I just made this up, but if I were to know this, I can predict the age of dog of any version, right? If I were to know 3 values of information, I know the age, something like that. And since all of this variable is the state variable, so it's the information that belongs to the state, this is called the equation of state. So this is another thing that a lot of work in thermodynamics focus on. So find the equation of state of your system, right? If you know the equation of state, then you can predict the behavior of your system. You can predict the property of your system, okay? Also, this AWHL, which is age, weight, height, and length, they are state variable because there are information that belong to the state. So they're state variable, okay? And also you can kind of rewrite this equation so that you have A as a function of WHL. You can rewrite this equation in 4 ways, right? You can write as W on the left side as a function of AHL, and there are 2 more. And when you write it like this is the function. So AWHL, which is age, weight, height, and length, are also state functions. So we'll use the term state variable and state function kind of interchangeably, right? So just want to let you know. So let's talk about the state of matter. So, like real system, right? So in thermodynamics, we always start with the simplest system we can study, and that would be monoatomic gas at very low pressure and in equilibrium. So I'll talk about why this condition is necessary maybe later on. But for given this simple gas, what are the suitable set of parameters that you can use to identify different versions of this gas? And it turns out that you don't need many. You only need 4 of them: volume, temperature, pressure, and mole. And I just want to emphasize that this is an incredible finding by really, really smart scientists back in the old days. Like, you probably heard of these names, right? Boyle, Charles, Gay-Lussac. And the fact that this system, real system, can be described by a very small number of information, and it doesn't really, it depends on the type of gas too. I think that was quite mind-blowing, actually, okay? So if we have this information, then we can define the state variable. So nothing surprising: volume, pressure, temperature, and numbers of moles, right? Because this is the suitable information that you can use to identify the state. So it's the state variable, right? And the relationship between the state variable is the equation of state. So a work by these people give you the ideal gas law or ideal gas equation of state, where R is the gas constant, okay? So before we end this video, I just want to emphasize that when you think about state, think about just a set of numbers. Nothing more, nothing less, okay? See you later.